Okay, question 5. Figure 11 shows part of the UK national grid system. So we know the national grid is a system of transformers, pylons and cables to move electricity from the power station to the home. And the first question says, what's the frequency of mains electricity? So we know it's going to be 50 hertz. Explain why the national grid uses high voltages with small currents. So done this a few times. We're going to need a high voltage A to push it across the resistance of the cables, but we want a really small current so the electrons don't bump into the positive metal ions and create loads of heat energy. So it's to avoid heat energy in the cables, which will reduce the efficiency. So model answer: prevents the cables heating, which increases the efficiency of electrical energy transfer. Right now we've got a transformer, and it says calculate the power in the primary coil, and we can see that's this one here. So this is the input alternating current. Use the equation P equals V times I, so that's our IP violently. So we've just got to find those values, check they're in the right units. So voltage is in volts, perfect. Current is in amps, perfect. Just got to multiply those two things together. Comes to 7680 watts or joules per second. Calculate the following for the transformer. We've got to do our coil ratio, and it's secondary over primary. So we've got NS over NP is what it's asked us to do. So we're just going to find the secondary, 1600, and divide it by the 80,000. Comes to 0.02, and it says, for the transformer, evaluate in its simplest form the ratio of the secondary voltage to primary voltage. And again, if I just get rid of all of these red scribbles now, let's get rid of that. So secondary voltage is here, 240, and the primary voltage is 12,000. So we can just write those next to each other like that, 240 to 1200, and we know we then see how many times the small number goes into that. So if I did 12,000 divided by 240, I get my simple ratio of 1 to 50.